Okay, in this video, we're going to talk about creating an Azure Load Balancer. Now, the idea here is a load balancer will allow us to balance incoming traffic across several virtual resources or virtual services. So, for this example, I'm going to use virtual machines as an example. Now, I don't actually have virtual machines that I have created to load balance to, but I do want to show you how we would go about creating a load balancer. So, and I'm going to lie to the system and pretend like I have things that I don't, but hopefully you'll be able to see how this works. So I just opened up Load Balancer, so it's right here, but if you don't have it there, you can do a search for load balancers and find your load balancer service here. And then we'll just create a load balancer. Now remember, this is to balance traffic across multiple virtual services. So let's say I have a handful of VMs and they're all running the same thing, website or something like that. We'll use website in this example, why not? And we'll have traffic coming into that, and I want the load balancer to split it across those virtual machines that are running my website. I want to do that so it doesn't put too much load on one particular one and cause everything to slow down. So I'm going to create my load balancer. So I'm going to click on Create Load Balancer. I'm going to do this in my demonstrations resource group. So you'll pick your subscription, your resource group, and then your name. And you're going to have lots of different things we're going to name here. So I'm going to call this Demo Load Balancer. I'm going to be really creative. Okay. The SKU, this is the type of service that you're doing. Now, the basic is going to be retiring. If we click here, you're going to see standard load balancer. It's the one that's recommended. When extreme performance is required, coupled with low latency, choose the gateway load balancer to deploy, scale, and run third-party appliances. I'm not, so I'm using a standard load balancer. Now, which type? I can do a public or an internal. Now, the difference is with a public, it's going to have a public IP address, so it's for everybody in the world to use. An internal is going to have an internal IP address. Now, it could still be for everybody in the world to use if I was running through an ant table, but typically what we'll do is if I want my website that I'm talking about here to be public, or whatever service that I'm using, right? It doesn't have to be a website. But if I want that to be publicly accessible, then I'm going to choose that I want a public one, and then I can put it in either a regional or a global tier. If I only want internal, so this means I'm going to be using this for my internal clients. So clients on my internal network accessing these resources through a load balancer in the cloud, and I want an internal IP address, then I'm going to use that. So I'm going to go ahead and leave it at that. Now we're going to configure our front end. Now our front end, our clients come to our front end IP address. And from our front-end IP address, then traffic will be load balanced across our back-end pool. So for my front end, I'm going to add an IP configuration right here. And this is going to be my front-end IP address. And I'm going to call this Demo Load Balancer Front IP. And it can be IPv4 or IPv6. I'm going to select my virtual network, and this is for my demo. So I'm going to do my demo virtual network. I'm going to select my subnet, which is going to be my default subnet. And then I'm going to give it an IP address, and I can make it dynamic or static. And since I have people connecting to this, I want that to be static. So I'm going to give it an IP address, and it's got to be in this range right here. So it's going to be 172.16.0. I'm going to do 15. And then how do I want my availability zone set? I can do zone redundant. I can do no zone. I'm going to do no zone here because it doesn't really matter. I'm just going to delete this in a few minutes anyway. But if I wanted this load balancer to be redundant, then I'd choose zone redundant most likely. So I'm going to save that, and that gives me my front IP address. Now, remember this IP address, 172.16.0.15, this is what my clients are going to connect to gain access to the resources that are supported by this load balancer. And those resources are going to be in the backend pool. So that's what I configure here. So I'm going to add a backend pool. I'm going to call this Demo LB Pool. And then for here, I can do this based on NICs or IP addresses. And if I had available resources here, then I would add my resources to this pool. Now, I don't have any virtual machines, which is what we're using as our demo here. I don't actually have any up and running because I've got a limited credit here. So I don't have any up and running, but this is where I would load them in. And then what will happen is when people connect to that front-end IP address, it will divide traffic across the devices here in my pool. So if I had, in this scenario, 3 virtual servers running, I would add the NICs for those 3 virtual servers. You can also do this based on IP address, and there's a little warning here. Backend instances are not secure by default and still use default outbound access. To secure your backend pool, please use an NAT gateway to your subnet or leverage the private subnet parameter. So I would do this most likely to my NIC. If I'm doing virtual machines, I could do it to IP addresses if I needed. And I do the same thing, is I would just add my IP addresses. So I'm going to leave that as NIC because that makes more sense for our scenario of doing virtual machines running a website. So I'm going to click Save, and that's going to save my backend pool. Now, obviously here, both on my front-end IP address and my backend pool, we see that we can do multiple ones, but we're just going to go with the one for the moment. So I'm going to go to my inbound rules, and I have 2 rules that I need, or that I can set. I don't have to. So the inbound NAT rule forwards incoming traffic to selected IP addresses and port combinations if I want to do NAT for my inbound traffic. I don't really need to do that, but I do need to add a load balancing rule. And let me close this real quick so we can see this. The load balancing rule distributes incoming traffic that is sent to select IP address and port combination across a group of backend pool instances. Load balancing rule uses a health probe to determine if they're eligible to receive traffic. Okay, cool. So I'm going to create a load balancing rule, and I'm going to call this demo LB balancing rule, and I'm going to do this on IPv4. So I need to select my front-end IP address. Now, you'll notice here with my load balancer having multiple front-end IP addresses, multiple back-end pools, okay, I can do multiple things with a single load balancer configuration. We're just going with one, but just to be aware, you could do multiple things with a single one. So I'm going to select my front-end IP address, and that's going to be my demo LB front IP. And then that is going to translate to my existing pool. So using this load balancing rule, this is where I marry that front-end IP address to the back-end rule. I can set high availability ports if I want. I can set my protocol under TCP or UDP. Okay, what port number? Now, this is the port number coming in. So in our scenario, remember, I said this was going to be a hosting web servers. So I want to run SSL, so I'm going to use port 443. Now, I can actually translate this to a different backend port, so I could have my servers running on something other than port 443 if I wanted it, and this would translate it. I don't. I want it to go straight across because I'm not doing port address translation here. Now, my health probes. So what will happen is the load balancer will send a health probe to the devices or the services that it's doing load balancing for. So if one of them goes down, it wants to make sure it's not sending traffic to something that's not actually there. That's what the health probe is for. So I'm going to create a new health probe, and I'm going to call this demo LB health probe. Okay, and then I'm going to set the protocol, the port number that I'm doing. So I want to connect to TCP on port 443. And then how often do I want this to go? Now, there's a little amount of time between probe attempts, doesn't really tell you a whole lot. The idea here is the more often you do it, the faster it's going to detect when a service or a VM in this scenario goes down. However, the more often you do it, the more traffic it's sending there as well. So a longer interval will result in less traffic for your health probes between your load balancer and your services, but it's also going to be a little bit longer if one goes down. There's more of a chance that traffic will be sent to a system that's not active. So I'm going to go ahead and set this to 15 seconds. I think I can deal with, if somebody tries to connect and they get sent to a device that's not functioning or one of my VMs that's gone down. It's 15 seconds. Okay, I can live with that. If they try again in 20 seconds, they'll get to the right device. Okay, I'm good with that. Okay. So there's my health balancer. And then session persistence. Session persistence has to do with during a session. So while a client is actively connected to a server, do I want them to stay connected to the same server or do I want them to bounce around during a session? That's what session persistence is. And you'll see here it explains a little bit about our session persistence options. So none means if I'm pulling files off a web server, the first one may come from server 2, the second one may come from server 3, the second one may come from server 2, third one may come from server 3. There's no persistence in the session. So I will bounce around to different backend servers in that pool during the same session. If I don't want that, I can set persistence. And so I can do this by client IP. Now, this might be a little bit of a problem. This is an internal one, so it's not going to be a problem. But let's say you had an external one and you had, somebody was connecting to your website that's hosted on these servers behind this load balancer from a large organization that use network address translation. You might have 70 or 80 people from the organization hitting all at the same time. And if they're all coming out through the same IP address, they're all going to hit the same server. So what you might want to do is change this to client IP and protocol. So that's going to be the port number of the individual session. So if I do client IP, then anytime I establish a session, anything else from that same IP address is going to go to the same server. If I do this based on client IP and protocol, then it's going to be from the client IP address and that same protocol or that same port number that's going to determine session establishment. So theoretically, if I have two devices connecting to me from behind a NAT table using two different IP addresses, but they're on different protocols or different port numbers, they could potentially go to different services. And then idle timeout, when do we time out the session? Do we want to enable TCP reset on the session? And do we want to enable IP floating, which is defined here? Exposes the traditional load balancing IP address mapping scheme for ease of use. Enabling IP floating changes the address mapping to the front-end IP of the load balancer to allow for additional flexibility. I don't need that at the moment, so I'm going to hit save. And that's going to give me my load balancing rule. Okay, I don't need a NAT rule, so I'm fine with that. Next is going to be my outbound rules. I actually don't need one of these, especially since this is an internal connection or an internal load balancer. So an outbound rule allocates source network access translation ports from the front end to the back end for outbound connections to the internet. They're not going to be doing that, so it doesn't really matter. Tags to identify it, and then review and create. Okay, everything passed. We've validated our configuration. We're going to click create, and now it's going to create that load balancer and then all the other things we created for it, the backend pool, the front-end IP address, the health check, all of those things. Okay, and it said it worked. So I'm going to go back home and to my load balancers. And this is going to show me my demo load balancer right here. Now, this is something that we may want to adjust on a regular basis, right? We might want to adjust our settings for persistence. We might want to add or remove different devices from the backend pool. There's lots of ways we might want to modify this as we go along. So we're going to click on our demo load balancer, and then I'm going to collapse this because it's annoying. And right here under my settings, here's where I can adjust my front-end configuration, my back-end pools. I can actually open my pool and I can add and remove devices from it. My load balancing rules, if I need to change them, if I need to modify my health probes, that's here. Maybe I want to decide that I want to add another protocol, so port 80 along with port 443. I can add that to my configuration. So lots of different ways. Now that I've got this up, I can go through and like most things in Azure, I can change most of them if I need to. So that allows me to adjust my load balancer as we go. Okay, there we go. That is your introduction to creating a load balancer in Azure. Remember, we can do this both for public and for internal access to resources. And we have lots of flexibility, but the whole idea of it is to be able to load balance traffic from clients across multiple virtual resources.